Mr. Pancharathnam needs no introduction to those of us from CMC, having been the General Superintendent here for quite some time. He took BE in Civil Engineering at Anna University in 1960, post-graduation in Structural Engineering, Anna University in 1961. Work experience, Engineering Tamil Nadu, PWD and Housing, Class 1 India Railway Service of Engineers, 1963 to 85. Personnel service in the railway for 5+ years, Superintending Engineer CMC Hospital, General Superintendent CMC and Hospital Vellore, Engineering Consultant to the Leprosy Mission in India, 2213. Fellowship of membership of many institutions and numerous projects in the railway service and in various other works in railways. Thank you, Mr. Pancharathnam. Welcome.
Good morning to all of you. And my talk is on the role of preventive maintenance and building safety. Now, as we heard, yesterday's speaker, he mentioned how the equipment maintenance gets very much less priority than even the vehicle movement. But I think everybody uses vehicles, so they're more concerned about its maintenance than the special equipment which we use. And definitely our buildings get even lower priority, although we spend very much more money on buildings than equipment or vehicles. This is a very universal phenomenon, and I'm not sure what the solutions are, because every time you approach somebody for some maintenance expenditure, they'll say that is not important. It is important. And I want to mention this particularly to all those who are looking after hospitals, that maintenance of hospital buildings is a very important function of the hospital working. Now, when we were young, at that time, the Russians had supplied MiG fighters to India, and our people, as usual, didn't maintain it to their standards which they required. So they sent one of their instructors to India and said, please train these people how to maintain and what to maintain. So they tried their best, but they couldn't break this barrier. So finally, the Russians in those days were very staunch communists. They didn't believe in God. But this instructor said, now I believe in God. So that is the way we continue to function. In fact, when you go around seeing the kind of maintenance that is being done, you definitely believe that God is a very strong component in the safety of all our working. Now, how to prevent maintenance. To me, the bottom line is that good and sound construction is the first basis. Unfortunately, we don't spend too much time and effort on ensuring that what we construct is really good and sound. Today, it is all fast food, fast construction, fast everything. So we are more interested in trying to finish the project than give a good and sound construction. It is very, very essential. And I wish those who are involved in the construction activities will hold this as the basic principle so that you prevent maintenance and prevent less maintenance in the future. Now, what do you understand by building safety? I mean, we may all have different ideas. To me, the two main classifications or heads are safe from health hazards. The second one is safe from physical collapse. Now, what I mean by this is that if I am in a building, I want to be very sure, because we live in buildings, we work in buildings, and I want to be very sure that I am not exposed to any health hazard. I am also not exposed to any physical collapse. So this is a very important part of building safety, and this is the two broad headings into which I have classified what I'm going to speak now. Now we take health hazards. We want it free of contamination. We want it free of dampness. These, I think, are two important aspects of health hazards. Now, what do we mean by free of contamination? Free of contamination is, we want, at least I would want, and I'm sure all of you would want, good, clean, fresh air, natural light, and a lot of ventilation which is available. In fact, all the hospitals or the projects that I am now involved in, I make sure that this is the prime requirement. I differ a lot from a lot of people who want everything to be made into AC. Everything's to be made into AC. And I have a lot of reservations about this AC business. We heard from the morning speaker that even abroad, and even his recommendation was that we should go in for natural light, natural ventilation, and that was provided in the old hospitals. In fact, even CMC, many of the old wards and many of the hospitals where I visit and help, the old wards, well lit, well ventilated, and you feel comfortable going inside. I have a personal bias against AC because I'm not very comfortable when I am in an enclosed space and somebody says that you are in an AC area, including this auditorium. Earlier it was quite open and we were very happy. A lot of fresh air was coming and going. And now, no, I'm not criticizing anybody, but now we have to depend on somebody to make sure that the quality of air is good. Similarly, when I travel on the train, I choose AC because of the crowd being less. If I had a choice like the old first-class compartments, I would definitely choose the first-class compartments. Because when you travel in AC, I don't know if you people have had this experience, people will cough inside the AC, right on your face. And morning we heard the effects of what these coughs can do. They will sneeze in front of you, and there is no way any of these germs are going to go out. I have acquired many of these infections by traveling in AC compartment. But there is no choice because, unfortunately, the sleeper compartment is so packed and full of people that it's difficult to even walk from place to place, even if you have a reserved accommodation. So these are my reservations about the AC, and I would prefer that we have natural, well-lit ventilation and air so that my health hazard when I go into a building is much less and I feel safer. Now the other thing is freedom from dampness. Now, we also heard what can happen when the buildings become damp. And very often we neglect this dampness. Dampness you can find on the roof, you can find on the walls, you can find on the ceilings. Now what happens when the room becomes damp? We heard that molds and fungi are formed, moss is formed outside on the top, and these are very, very harmful for people who live or work or have to stay in a hospital environment. And I know in many places we have tried to clear this mold from the walls after it has dried up. And I have had to tell the people there, please at least put a mask on your face, because they'll go on wiping with their brooms and spreading the spores and fungi all around. And any inhalation of this kind of an air is really bad for health. And I'm not sure what the treatment would be or what the cure could be for that. But this is very present, and we should avoid dampness. Now, on the rooftop, you will find water stagnating. One of the first principles of good drainage is that no water should stagnate anywhere. In fact, once when I had come here, there was a guest lecture of somebody talking about rainwater harvesting. Now, this gentleman, I'm not sure, I'm not being critical, please don't take it that spirit, but I'm not sure whether he really knew what is rainwater harvesting. But he was invited here as an expert, and I was in the audience. And he mentioned that Vellore gets 40 inches of rain. So we should construct your terraces as water tanks. And all that water will be stored, and you'll be able to get it whenever you want. So I kept quiet. I mean, I didn't want to raise any questions. I was sitting quietly. When I came outside, one of the inhabitants of the quarters here, he said, "Such a nice idea. Why didn't you people think of it?" And then I had to remind him that our entire effort is not to store water on top of your terrace, but to remove it. Because our slabs on the roof slabs are not built to contain water. Please remember this very carefully. I am very much against putting water tanks using the base of as the roof slab. There will always be problems. And it is not at all advisable. Even if you raise a water tank above the roof level, you'll find that below that there'll be water seeping, there'll be moss collected, which will nicely soak in the water and allow it to go through into your roof. And also, you will find that this water, the overflow pipes, will be draining onto the roof. Anything that you pump, if you're over pumping your water, you'll find that it will come and drain onto the roof. I always keep telling people, please put this pipe outside. Take the water out. Take out all the water from the roof. Please don't allow any water to come onto the roof. Make it clean and free of water. The other thing is that I differ from the architects in many ways, and because they will have various levels of roof. And I have had problems with one roof draining onto a lower roof, and from that roof onto another place. And recently I've just come back from a so-called technical audit of a building in Bhubaneswar. Now the top terrace rainwater falls onto the roof in the first floor. I told them, please take this water out. This roof is not meant to take this kind of water flow from one level to the other. So this is really the crux of the problem. We should make sure that the water goes out. And the slope of the roof should be so planned that the water goes out. You'll find, if you go through many buildings, there'll be just one outlet pipe, and all the slope is so-called turned towards that pipe. How can it drain all the water? Take it out to the closest way. You may think the pipe looks ugly. You may try to bury it, which is even worse. Because once it is buried, you really don't know what is happening inside. Your walls will start getting damp. You don't know what is happening with the pipe inside. Because I have had an operation theater in one of the hospitals where during the rain, suddenly they used to find water coming from the bottom. I said, this is a wonderful phenomenon. So they said, please come and have a look at it. When I went there, I found that the inlet pipe, the inlet of the drainage pipe was not properly sealed. After all, who seals it? One maestri who cares two hoots. He will go there, do a little plaster near the opening, and then the water comes through the wall. It had come through that and came through the flooring. So every time there was a rain, there will be water bubbling up from the floor. So this precaution we should take, that all water is cleared from the roof as quickly as possible. Now we have waterproofing people, waterproofing agents, and the problem with all these people, I am very skeptical of these people, because I have had to redo many of these waterproofing done by the so-called agents. They will give you guarantees, they said. Now what is a guarantee? I said, have you got a money guarantee? No, they will come whenever we call them. please remember, all of you, nobody will come. And we have had instances of firms where I said, please write a registered letter to this firm. The letter came back saying that address is not found. Now, you should take a lot of precautions when you do this kind of waterproofing. All of you would have heard of tar felt, 2 layers of tar felt. Now, many places I have seen that this tar felt gets punctured and the water goes under the tar felt. It's kept safely till it drips through your roof or comes through your roof, because it's protected from the atmosphere also. I don't believe in all these things. And if and any time you do waterproofing, when we were young, we had a very excellent system of waterproofing. There used to be this brick jelly concrete over the roof, which was both water plus weatherproofing. Excellent system. And there will be 2 masons sitting on either side with a knife-edged long rod, a triangular rod, and the knife edge will be used to tamp down the concrete. That kind of pressure was given, and they will do it slowly. They won't do it fat, and go and finish and say we finished. Slowly, little by little, and the final product is so hard that if you want to take it out, you really have to break this waterproofing course. But it was waterproofing. Today, the same thing, if you go and see, it is being done. But if you see, quickly they will spread this concrete. And then I said, what about tamping at least? Yes, we're tamping. Gets a little rod and tamp all around. This is not waterproofing. And therefore, you will have problems. In fact, good concrete, if it is done the way it should be done, is totally waterproof. All this is because we don't do good concrete. And there is a rather cruel joke on the civil engineers saying that if it is not cracked, if it is cracked, it is concrete. So that's the impression we have given to people all around, because that's the fact. You go to many places and see the kind of concreting done. That is what is happening. Now, the next is, what kind of collapse of a building do we expect? It could be either sudden or it could be gradual. The sudden attacks, one of the trickiest groups of things are termites. Now, wherever there is a lot of timber, of course now it is reduced, we now use only concrete, aluminum and other metal things. But here in our campus here and some of the old buildings there, we used to have these timber rafters going across. And then you'll never know what is happening inside. So our maintenance people must go and tap this rafter. You won't see anything outside. There is no visible sign. They'll tap this rafter, and then if you hear a hollow sound, you know that the inside is gone. So immediately here, of course, we used to replace these rafters with, again, precast concrete rafters, and pull out one, insert a concrete rafter and replace it. And we have done it in many buildings here. But this termite is a very tricky thing. You heard about this bone marrow transplant, bone marrow treatment plant ward in CMC. The first ward, which was put up in the so-called M ward area, was on the 2nd floor. And God knows from where. They are so particular about even viruses and germs going in. The termites were in. We really were surprised, because somewhere through the wall and through some opening, termites had gotten. They're very tricky chaps. And in my house here in Vellore, my wardrobe is right in the center, and center of the house. It's a built-in wardrobe. And for some time, one half is my wife, one half is mine. And I keep all my precious records on the top shelf. So once we were out for a few months, both of us, and when we came back, I found one trail of white ants going inside. This is right in the center of the house, not even the edges. And then I was really worried, because it went to the books and the important documents that I keep. And there was a plastic file which contained all my original certificates. And these termites chose to attack only that. They left all the other books. So when I opened this file, my original certificates were full of termites and in powder. So today I have no original certificates, but of course I don't need it at this stage, but they're very tricky. I mean, this is the last place I would have expected termites, but they had come in through the bottom, they had eaten up the frames of the wardrobe, which was apparently intact, but they had finally caught my certificates and finished it. All other books and things they had left alone. Only my certificates for the victims. So they are very tricky, and I would impress on all of you that before you start any construction, please do termite treatment. Because after you construct, there is always a problem of how to do this termite treatment. You'll have to remove everything, they have to drill holes, and even that is not a full assurance that you have removed the termite, because you must attack the nest and kill that queen bee whose job is only to keep producing termites. Now, the other things are that earthquakes. Now, Vellore was never in the earthquake zone when we did our study of engineering. We never had it. And when I built my house here, I never provided for earthquakes. But there was earthquakes in Vellore, and my house cracked badly. So we never know when and where these earthquakes come. In fact, I was asked to inspect one building near in Nashik, newly built for the leprosy mission, newly built, well built. And I was telling them, it's a single-storied building. They had put RCC frames for this building. I said, why? There is hard rock just a couple of feet below. I said, you can straight away put the foundation on that rock. Why did you think of frames? And I was asked to certify the building. I very gladly certified it fit for occupation. A couple of months later, I was called to that building to come and see. And I was shocked to find that so many cracks had occurred in the building. I said, I really can't find an explanation for this, because there's no chance of any crack occurring. There's no chance of subsidence. There's no chance of anything. And then it struck me that Nashik is not very far from Latur, which is earthquake prone. So somewhere an earthquake has occurred, and being founded on this rock, it provided a nice vibration. Because nothing happened. The RCC slabs were good, the beams were good, everything was good. But this earthquake had happened. And you can see the cracks, you can see between the filler walls, you can see through the cracks into the other rooms. So take that as always into account when you think of buildings. Finally, terrorist attacks. Now, I've deliberately included this because we are heading for a stage where it's going to become commonplace. Just like a traffic accident, you're going to have some terrorist attack in all places. Can we prevent it? I don't think we can. In fact, the classic example of terrorist activity is the World Trade Center building, which was brought down. And when I was reading the articles, in 15 seconds, 110 floors of the building was reduced to a pile 9 floors height, just in 15 seconds. So, because even that building had been built to take into account all kinds of forces, earthquake, founded on hard rock, but one terrorist plane attacked this bridge, this building on the top. And the fire there created a sort of opening of all the columns, and the whole thing settled one by one, right up to the bottom. So we are never sure what we can do, but we have to keep that into account. Then we come to this gradual collapse. I think I'm going to exceed the time, but if you don't mind, I'll carry on. Gradual collapse. The basis and indication of this is cracks. We have got two classifications. One is structural cracks, which is due to incorrect design. Somebody has not calculated their things properly. It can crack. It can lead to failure. The next is overloading, very common. In fact, in one of the buildings, they said, we are having a problem with this thing. And when I went and saw, there was a huge cooler, 1.5 tons, kept right in the center of the roof, which was not planned to be taken. I said, please take this and put it on the ground floor or take it out from here. And then we keep on piling up all kinds of materials on the roof. We cannot do that, we cannot overload, because all structures are planned only for a particular load. Then vibrations. Vibrations from all kinds of equipment. We now hear of the metro railway creating vibrations and creating problems in buildings. You have vibrations of machinery working around you. You have vibrations of trains passing by. I have actually stayed in a flat where the trains used to pass by, and every time it went, the whole thing will shake. That was only a train. Aircraft passing by, all these things cause vibrations. Now, non-structural cracks are moisture variation in foundations, because in clayey, shrinkable soils, moisture variation, if water gets in, the soil will expand. The minute water goes out, it will contract. So it will keep like an accordion going up and down, creating cracks in buildings. Some of it can be serious. A lot of it is just, it will open, close, but some of it can be serious. Temperature variations cracks, causing, can I carry on? I'm almost through. So temperature variation cracks due to expansion and contraction. Now you have long buildings, there has to be expansion joints, because all buildings expand and contract. And sometimes these expansion contractions are different for different materials. See, the concrete slab will move differently, the brickwork will move differently, and that also causes cracks and problems. Then ground movements. Now, ground movements are where you have landslides, you have sudden sinking of the ground, then you have your neighbor is excavating a foundation near your foundation or your building. Nobody controls it. You will find many places in crowded areas, somebody is going on excavating, and quite deep. And I don't know what protections have been made. There are no protections. Only God is protecting such things. Then trees and plants. See, we all like to have trees near our buildings. They are supposed to provide shade, but they don't really help in a way as far as the foundation is concerned, because the roots come through, particularly load-bearing trees, load-bearing walls. They get disturbed by these trees and plants. And sometimes, even if you cut the trees, you have to wait for some time for it to die before you start constructing, because the roots are still fairly active and can create problems. So finally, in conclusion, before I say thanks, do we have a system of maintenance? I don't think we have a system, because we don't like systems. But I come from the railways, where we have systems for everything. This has been handed down to us by the Britishers, who were the people who were running the whole show. Everywhere there's a system. Every time when the rain comes, when you people go through on the trains, you'll hear a whistle. Be happy, because that is the petrol man going up and down the track, and he's supposed to whistle every time a train passes. Then we have the track being maintained. There is a program, a sheet. So when you go on an inspection, you'll know what this man is supposed to have done, the gangs, go back, check his work. There is a system, everybody knows, yes, this is my work, this is what I have to check. Every bridge, every tunnel is inspected and certified every year by a senior engineer of the railways, starting from the assistant engineer, executive engineer, or the bridge engineer. So there are systems. Now in buildings, what I can suggest to you people is that please go around the building, find out where your cracks are, then go inside the building, find out whether there's an impact of this crack inside also. Go to the roof, which is the most important part. Please make sure that before the rains, the roof is clean. You'll find lots of trees over the roof shedding their leaves. And the roof is full of leaves, full of debris. Water cannot find a way to the few outlets that you have provided. Please have it cleaned nicely. Please maintain the roof, particularly before the rains, and during the rains, make sure that the water is going out. This is a very important part to keep your building safe and keep your structure safe. Thank you very much.